All right. Hi, everybody. Session today is about how do we accelerate or how we accelerated Iceberg queries for CDC and merge on read using equality deletes. My name is Roy Hassan. I'm the VP of product at Absolver. A long history of system data engineering, solution architecture. Been around the block for a while. You may have seen me on LinkedIn. If you haven't, follow me. Would love to get your thoughts on lots of my stuff. So anyway, what I want to talk about today is really delivering high value data to Iceberg tables and how do we manage the performance, especially with Presto. So starting from kind of the bottom part and moving up, Iceberg is around shared storage, right? The important part about it is that it gives you a consistent layer for both storing and managing your data that's accessible to any number of tools. So if you look at this, this is kind of the storage layer of a bigger architecture where Iceberg and Parquet play an important role. If you take a step back and you look at a higher level, right, 30,000 foot view, that shared storage component it's part of a bigger lakehouse architecture. And Iceberg plays an important role in being able to deliver both ETL and ELT and a lot of the services that we used to and we love on top of a data lake, something that was hard to do, complicated, and just create a lot of friction for users. Now with Iceberg, we can deliver the same capabilities similar to what we get in data warehouses, but get all the benefits of data lakes with unlimited storage and lower cost and ability to kind of pick and choose your tool for the best job. More specifically, when we look at kind of the analytics workloads, change data capture is one of the common use cases that come up, and why these table formats that support updates and deletes on top of object store became very, very popular, because managing CDC on top of S3 or Azure or Google storage, it's actually kind of hard. You can do it, but there's a lot of code that you have to deal with in order to deliver that. So Iceberg and Hoodie and Delta really make that easy. So in the grand scheme of things, we're talking about continuously moving events into a target that then has to be continuously updated and modified and incrementally changed. This is a world where we're seeing sort of the batch use cases transitioning towards more of the near real time or even real time use cases, requiring our engines like Absolver, Flink, Spark, Rising Web, some of these other ones to really come into the forefront as a way to deliver continuous data into the analytics stack. But how do we do that in Iceberg? That's something that comes up all the time, and our users are asking for this. And at Absolver, we have this need as well. We have multiple databases internally that we use for applications that we want to store, export and store in Iceberg so then we can analyze. So in Iceberg, there are really two ways to do merge on read deletes or kind of handle deletes in general. First one is position deletes. The second one is equality deletes. Position deletes is very simple. Basically, you figure out which row needs to be deleted. You find what file it lives in, and then you find the position within that data file where the row is, so you know how to delete it. Now, to do that, when you're writing data and you're writing a new delete row, now you got to go and search all these data files, scan through all of them, find the position in that file, and make a note of that, right? So every write requires full file scan across all of the files that are in your current partitions. Typically, that's a lot of files. It's a pretty heavy operation. On the read side, it's fairly simple to be able to merge those results and remove the so-called deleted rows. So for a query engine perspective, it's not that big of a deal. But for writing, especially in CDC use case, when you have continuous, potentially high volume of changes, this becomes a real problem. So to solve that, Iceberg introduced this concept called equality deletes. So instead of scanning through each file to find the positions, you now just put in the column name and the value that you want to be able to delete. So this is where you look at it and you say, any rows that has column primary key and it equals 1x blah, 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 I want to delete that row or not include it in the output. That makes writing data a lot more efficient and faster. But in the current implementation of merge on read, especially in Presto and in some of the other engines, that isn't really well optimized. and it results in really slow query performance. So we set out at Absolver to solve that problem because that's the biggest use case that we see with our users and also for us internally. So when we look at this, when we look at kind of the original implementation of Presto, it was very specific to how position deletes are handled and how any files are handled inside of Presto. So when we look at our files, we have data files, and these data files contain the actual rows. And then in Iceberg, you also have to create these delete files. And the delete file is just like a data file. And as I said before, it includes the column name and the column value that we want to delete in the equality delete files. In Presto, what happens, each of these files get sent into a split, right? Split's kind of like a work unit inside of Presto. Now, what happens is for each delete file, in order to know which row within the file to delete, Presto would read all of the delete files, right? So if I have one delete file, no big deal. It's split, open up its data file as well as one delete file. But if I have a lot of delete files, meaning I'm deleting multiple rows continuously and I'm generating more and more delete files, each split within Presto would have to open all of the same delete files over and over and over again, right? So just create the massive IO amplification at query time, which resulted in, clusters going out of memory, queries running indefinitely and kind of crashing eventually. We saw this across the board with just queries just simply timing out. So this wasn't working. We really need to find a better way to do it. So in Presto 286 was committed, and we introduced a PR or an enhancement to change this behavior. And the way that we handle this behavior is simply saying, okay, instead of reading the delete files from each split, we're actually going to read the data files and read the delete file if it was just a regular data file. And then we're going to be able to basically use that, and we're going to broadcast that delete table set, right? We're going to broadcast it to all the other nodes, and then we'll do an anti-join that joins the data files with the delete rows and produce the results. So that kind of take advantage of Presto's inherent capabilities around splitting data, distributing data, and doing distributed computation, and really take advantage of that capability to get better performance. So if you want to read more, I have a link at the end, but you can go check out 286 under the Iceberg improvements. You can go deeper into the PR and kind of what we did. But at a high level, we really simplified and streamlined the operation. So instead of massively reading all these data files, we read it once from one split, we broadcast join it to the other rows, and then produce the results. So with that said, if we look at the first picture here, when we ran this without this optimization, what we saw was almost a 5-hour wall time for a simple query. It's about a 5 gigabyte of data, 150 delete files, which isn't a lot in the grand scheme of things. When you have a database replicating, CDC changes, you're going to get a lot more than 150 delete files. It took 5.5 hours to complete that query. But once we implemented that enhancement, that wall time just went down to 39 seconds, which is completely reasonable and acceptable for what we want to do. So that's a massive, massive win for Presto community and for folks who want to actually run queries on Iceberg tables based on CDC workloads. So really super easy to get started in Presto, version 286 and greater. Actually, these are enabled by default, but Iceberg enable merge on read mode to true. Iceberg delete as join rewrite enabled, long name, set to true. It's on by default, but if you're running your own cluster or you want to play around with it and test it out, this is how you configure it. You want to dive deeper into the actual PR. 21605 is the one you want to get into. If you have any questions, reach out to us. Be happy to work with you and explain it further. I do want to say thank you to Jason Fine. He's our chief architect at Absolver. He is the one who did all the work, wrote all the code, submitted everything, and kind of pushed that through. So, hands off to him and all the work that he's been doing. He's actually submitted something similar to Trino, and we continue to optimize and improve Iceberg and also Presto as we move forward and add more use cases. So with that said, if you want to actually watch the full video of Jason talking about this, not just 10 minutes brief, there's a link below, or go to the Absolver YouTube channel. You'll find all the Chill Data Summit talks there, a lot of other cool stuff there. So with that said, Thank you very much for your time. I appreciate it. And that's it. Thank you.